When the switch is closed, conventional current will flow from the positive terminal of the battery through this ammeter, through the 2 ohm resistor, and back to the negative terminal of the battery. Now, one thing you should note, even though the switch is closed, you must understand that the EMF of the battery, it is going to remain the same unless you place another battery with a different EMF in the circuit. For as long as you are using the same battery, the EMF of the battery will remain constant. So the EMF of the battery will still be 1.5 because that is the maximum amount of energy that the battery can provide in this circuit. Now, one observation is that you will see that the V external one, which is the one connected across the terminals of the battery, it will have or it will read 1.2 volts, which means we are noticing a voltage drop from the previous example where we had the switch being open and the EMF was equal to the V external. Now, in this example, we can see that the V external is less than the EMF, so there is a voltage drop. Now, this brings us to what we call lost volts. What are lost volts? These are volts that are used within the battery. Since a battery has an internal circuit, and that is internal circuit, it is caused by the internal resistance. There will be some internal voltage, which is the voltage used to drive the total current through the battery. So a battery has internal resistance. That is the reason why we can see that whenever you have a battery connected to a circuit, it becomes warmer or it becomes hot. This is because the electrical energy from the internal voltage, it is being converted into heat energy. And this is due to the internal resistance. Voltmeters can only measure the external voltage. The only way we can determine the internal voltage is by using the following equation. Now, this equation explains to us that the EMF, which is the total energy of the battery or the maximum energy of the battery, it is going to be divided into two. It is going to be divided into external voltage, which is the voltage outside. This is the external voltage, and then also it will be divided into what? Internal voltage, which is the voltage found within the battery. Now, if we substitute the information that we have, we can see that we can substitute the EMF of the battery, which is 1.5, the V external, which is the reading from the voltmeter, and now we can use this information to determine the V internal, which is the internal voltage of the battery due to the internal resistance. And we can see that the internal voltage is the difference of EMF and external voltage. Now, if we solve for internal voltage, you will see that it will equal to 0.3 volts. These are the volts that are used for the internal circuit, which is within the battery. Outside the battery, 1.2 is used, whereas within the battery, 0.3 is used. When you add these two together, they must give you the total maximum energy, which is your voltage, your EMF actually.